if we want to summarize how much of liquefied wood or wood is left in the final product, unfortunately it's only 20 to 10%. The reason is that because you have to use this polymeric isocyanate, which is necessary in this case, and that's why this percentage is so reduced. On the other hand, I would like to show you a little, let's say, demonstration what is going on with these waste materials. The disposable chopsticks in China are a problem because they want to prevent forest. And those disposable chops, of course, after the use, they are left over or they are just thrown away. So they say, well, to prevent forest, they invented a special tax for these disposable chopsticks. I think it's about 5% on the price or something like that. As you can see, 500 grams of wood is made or is calculated from 75 pairs of disposable chopsticks. If you liquefy this stuff, you will get about 1,000 grams of liquefied wood. And this 1,000 grams of liquefied wood will give you about 1,170 grams of linear polyester. And if you go on with this transformation to polyurethane foam, you get at the end 2,930 grams of polyurethane foam. As I said in previous slides, because of polyisocyanate addition and so on. And at the end, you can calculate that one chopstick will give you almost 1 liter of polyurethane foam. Well, that is, let's say, the idea that the Chinese can use for these chopsticks, disposable chopsticks transformation or utilization. Well, the next very, very successful application of this liquefied wood was the use in adhesive in furniture industry. I think I shall show you the next slide first. You can see how much of adhesive is used in the production of, let's say, particle boards, medium density fiber boards, and so on. These are very, very big numbers. And because we were targeted in this particle boards production, you can see that if we can change, if we can, let's say, use our products in this particular branch of industry, 1.2 million tons of adhesives are used yearly. So if we approach, or if we replace approximately 30% of this stuff with liquefied wood, I think that is really, really a big achievement. Of course, we didn't stay just with this particular industry. We tried also with plywood and so on, and we know that it works. It's simply, if you replace a certain amount of classical adhesive which is used in this type of products with the liquefied wood, it works. With the, let's say, the same mechanical properties of the final product, but there is also a big advantage in this application. That is, the formaldehyde release is reduced more than 50%. Because the products after the liquefaction of lignin are some kind of formaldehyde scavengers. And therefore, it is not just the reduction of formaldehyde release because the addition of something else, but it is also the reduction of formaldehyde because of this scavenger present. And as you can see here, let's say the standard formaldehyde release with the standard use of standard adhesive, it's more than 5, 6 or something like that. But we have achieved quite a lower number. And the last application that I would like to talk about is the liquefied biomass as a liquid fuel. As you remember from these previous slides, we can liquefy everything. The broken furniture, for example, from these waste depots and so on. And because of this relatively high combustion or heat of combustion, which is higher than, let's say, brown coal or dry wood or something like that. We can use it directly in the central heating oven. No problem at all. A little modification of this nozzle and a little preheater is needed because of the, let's say, high viscosity at the room temperature, and then it will burn very, very merrily, and it will heat up the, let's say, a small house or something like that. The drawbacks, of course they are drawbacks. Because of the acid catalyst, the product is corrosive. So it must be stainless steel or brass or something like that. And then you can easily use, or plastics of course, then you can use this liquefied wood directly as the fuel. And of course the sulfur, which is present in small amounts because of this catalyst which we use, that is paratoluene sulfonic acid. It's again, we must be careful how much it is left in the product or in the fumes. But okay, let's skip this. On the other hand, why should we not use this liquid fuel in more sophisticated engines? For example, diesel engine or gas turbine. And we found out that the diesel engine is more difficult because these small particles which are present, sometimes they can easily it's not suitable as it is. On the other hand, the liquid fuel, as in the gas turbine, it works well. I will show you some slides. First of all, we had to prepare some kind of fuel delivery system. We heat up the liquefied wood to 100 degrees, where the viscosity is grossly reduced. We also use some industrial filter to get rid of bigger particles. And then here is, let's say, the test bench for this testing. As you can see, this on the center of this slide is the combustion chamber. This combustion chamber was taken from the MiG-21 aircraft. For the illustration, it is the same as it is here in this photograph, which was taken in some flight museum. And on the end, of course, on the right side, this is the turbine, which could be used for the, let's say, for the electricity production and so on. And of course, there is also a recuperator which can preheat the air which comes into the combustion chamber. So it means that the yield is much better. I think that this is something that has a big future because we think that maybe 100 kilowatt system can be easily put in the production or to produce some electricity in, let's say, together with this pilot plant on the site. It can be easily be applied and organized. And some economy. Is it really the economy okay? We calculated let's say the energy which can be obtained from the liquefied biomass in combination or to compare with light heating oil, natural gas, and so on. And so you can see the liquefied biomass is already cheaper energy source than, for example, propane, butane, or natural gas. No, natural gas is cheaper, of course. But because we have so much wood, it's really no problem. And to finish my presentation, I can say that we have replaced a certain amount of materials obtained from the crude oil production with the proper biomass, which is really in large quantities available in Slovenia and perhaps in some other countries as well. We are optimistic about using this liquefied wood as a fuel source in some power motors for the electricity production. And the main point is that these adhesives which we have developed or modified, I think that this really has some future in big industrial facilities. Thank you very much.
Thank you. Any questions?
Yeah.
Have you measured the emissions produced from the liquid fuel?
Yes, CO is in the range as demanded by the let's say standards. Nitrogen oxides as well. The problem is only sulfur, but the sulfur again it depends of the production process. If we increase the amount of the wood, which will be liquefied in this formulation and so on, also the sulfur will be reduced in that amount that at the end we shall have I think within the limits.
Did you measure dioxins?
Well, dioxins are not present, should not be. No, because where could they originate from? Okay, the tests which we have done were based on the liquefied wood, not the furniture but the wood. But that's another story. I agree with you. I suppose that when we shall, let's say, mill the waste furniture, and then we shall use it as an adhesive, not as a fuel.
Thank you very much. We
Thank
now
you.
give the word to